Hello, folks. It's George Leoniak, and welcome to New Geometry. I'm thrilled to be here today. Today's going to be an awesome video about what I call the tree of light, which has to do with this nonagon shape. And I'm going to talk today about the expansive possibilities with this for growing new polyhedra, as well as how it's related to some of the polyhedra that already exist for thousands of years. So we're going to expand that model out quite a bit to make bigger and bigger trees of light, and I'm going to show you a few forms that show up along the way in there. And I've got so much content on this right now, this is going to be a part one type of video, but it's going to take us pretty far into what is possible with this nonagon. Okay, I'm just going to share my screen and we'll hop into the presentation. This is a tree of light. I love the name because the tree, it looks very tree-like with the 9 points and the base 2 points there. And the history of this tree of light, for a long time, I've been calling it Coxeter's, H.S.M Coxeter's stellation diagram, the famous mathematician of the 20th century. But I realized through a few apprentices digging deeper, and it's actually in front of his book, the Icosahedra stellation, the 59 Icosahedron stellation, that Max Bruckner in about 1900 was the first person that we're aware of that started to work with this diagram and did map out some icosahedron stellations with it. Now, George Odum is often credited with the discovery of the extending the edge of a triangle to the outer circumference of a circle to produce golden ratio segments from this central triangle extended to the outer circumference, and you get golden proportion on either side. But for whatever it's worth, that discovery was at least published by Coxeter maybe in the 60s or 70s, maybe even 80s. But you know, Bruckner must have known about that in order to create this diagram in the first place back in 1900. But nevertheless, this diagram is full with golden proportions all the way through here. You probably have to zoom in a little bit on this to kind of check out. I'm not going to go through all the numbers, but we've got, of course, 1.618 showing up. The 2-inch edge length is a big one. The base of it is 1.61 or 0.618, of course. The 1-inch edge length is A to B, which is the length of the central triangle. Now, if we were to make the outer edge just one other proportion that's quite important about this, if the outer edge length between M and F over here were 1, then if it were turned into a nonagon, this edge length here between M and the pinnacle here, that would be the square root of 2. And I think that's what makes this nonagon a really good structural building block with the other polyhedra rather than working with the regular nonagon. So we're going to go through a number of forms, some new ones, and this one is an oldie, right? And this one is, an Archimedean solid, first enumerated by Archimedes around maybe 250 BCE. And, it took me for a while to look at these forms and actually kind of have eyes to look into the form a little bit. Beyond the surface, hidden below the surface, is the nonagon shape right here, the tree of light shape, right with inside the plane, as if looking through a plane of the form from the tip of this pentagon. It's going through the square face, which would be the square root of 2 across the square face, to the base of the pentagon, through the square face, through the square face, across the base of the pentagon, and so on and so forth, all the way around. And then we can draw on that star in the middle, which sometimes is necessary and sometimes not, but it just illustrates that that is the star in the middle of the nonagon. So it must be a lot older, at least hasn't been discussed or talked about, but I'm just trying to illustrate that this is not something that someone just came up with in a mathematical equation or experiment of some sort and said, let's just start working with this nonagon. It was already inherently built into the forms and the Rhombicosidodecahedron, which the Zohm ball, which is one of these little ball connectors, is modeled after, with the pentagon, and this has rectangles and the triangles. It's made of those 30 square faces, the 20 equilateral triangles, and 12 pentagons. Well, that's a Zohm ball. And, right within it is the tree of light. Now, the Zohm ball is proportioned a little different because of those rectangles, but nevertheless, you get the idea that with the Zohm ball, recently, probably a few months ago, I discovered that I actually could produce the nonagon, so I could hold it up and wave it around during the presentation. But I could build the whole Rhombicosidodecahedron out of it if I wished to. But I'm only showing a fragment here of kind of the top slice of just what I showed you before, from the tip of the triangle and pentagon through the square face, base of the pentagon. You can see how that maps out. And then my drawing is directly below that, because this is a simple drawing to do with the extended version of the seed of life, extending that the central triangle out to the outer edge of the circumference of the surrounding circle, and just connect the dots. And then we're able to pretty much draw in, and I've shaded the colors, the top portion of the form here. So that is one of the main places it showed up, but I'm always asking what's even below the surface. What's inside here? Is there anything driving the form, or with underneath the structure? Okay, so this will become important in just a little bit, but we've switched views here. We were looking pretty much at the triangle view here before, the hexagon view, I call it. And now we're going to switch to a pentagon orientation of the same form, the Rhombicosidodecahedron. And the blue form inside is a icosahedron with facing the vertices. So that's 20-sided Platonic solid, 20 triangles, equilateral triangles. And I had a hunch that there would be some sort of relationship between the underlying structure of that icosahedron relating to what's going on with these nonagons. And that is what's going on, is that the triangle of the icosahedron in blue, and we're extending the phi ratio edges of that triangle, right, in the red dotted lines, and that is going to produce the 6 of the vertices, including the triangle, equilateral triangle that would be inside of this, the 9 vertices, the 3 and the 6 equaling the 9. We're getting this piece of the Rhombicosidodecahedron, and once again, that's below the surface. But if you do that on all 20 faces of the icosahedron here, what will happen is you'll produce all the vertices of the Rhombicosidodecahedron. So it is like a way to grow a Rhombicosidodecahedron is to extend the triangle faces of the underlying structure, the icosahedron, into these golden proportion nonagons, and that will then create your Rhombicosidodecahedron. A really nice integrated link there in the form. Here are just a few other examples of, I've removed the Rhombicosidodecahedron, just kind of focusing in on, here's that same face, right? And these are all these points, which are just amazing to me, are just picked up in the diagrams of the pentagon view. So the can pick up all the vertices to actually draw the nonagons in the drawing, right? Because we could basically draw the whole Rhombicosidodecahedron. So we're basically just showing where each of those slices are of the nonagon planes, trees of light. Okay, so that's a nice intro to something that's over 2,000 years old that has been below the surface in the geometry as a structural piece. We made it a connection to the icosahedron that rests below it. So it's not really something that is just of the 20th century and Max Bruckner's work. They did a lot with the icosahedron stellation diagram, which gives you 59 icosahedron stellations of working primarily using that as like a cutting template, the form itself, the drawing itself, which has some additional lines in the middle, and you pull out particular pieces, and then you'll go ahead and recreate a number of different awesome looking models. And a fellow geometer, Danny Burgess, is doing extensive research and job of drawing these models from all three views, the major views, square view, pentagon view, and hexagon view, and it's quite a cool journey. But one of the first places that the form of the Nonagon became really apparent to me was, of course, through the icosahedron stellation diagram, because in the beginning, I thought that was just about all it was. And but the first place I noticed is, once again, I asked, well, here's this echidnahedron, the 60-pointed final stellation of the icosahedron, right? And I wondered, well, what are actually these pentagon vertices? Like, where are these little pentagon? Where is that showing up? Does it relate to anything, or is that the end? Like, is this just it? Is it disconnected from anything else around it? Well, I was pleasantly surprised when I found out that the whole echidnahedron, this spiky form, what you think is way, way out, like well beyond the dodecahedron or any of the Platonic solids, no, it's contained right in the dodecahedron, because all of the 60 vertices match up precisely to the cube edges, I call them, but they are, we'll just call it the star on the pentagon faces. All those vertices will end up at the small pentagon at the center of that star, which is actually the crossing of 5 edges of the cubes that are in the dodecahedron. But that is all the way around the whole form. So this echidnahedron is right within inside the dodecahedron, which is just really cool. That it happens to be, part of the structural, the geometry just of a core Platonic solid, not just something that's way out there, and it has this relationship to the cube. Now, I've marked these locations to show the 9 points. You could say, oh, this is the root 2 section. This is 1, root 2, root 2, 1, root 2, root 2, 1, root 2, root 2. That's the way it goes around. Well, if you kind of remove everything out of the form at that point, you'll see that that really is just a flat plane. Now, it's not through the core of the form. That's originally what I thought. It was like right at, the base horizontal level. It's actually building off of one of the faces. So you have a face above and a reverse face the other way, and they're kind of hovering up above. You still have a core plane, which we're going to get to in this video a little bit and in subsequent videos of what's going on at the core through these forms. But for this one, you could see that 2 points down here, just that flat plane, right, looking down, because this is an icosahedron stellation. So this is the triangle view is kind of the dominant factor of how we're going to view this. Now, if we flip it to pentagon view, the icosahedron stellation diagram will rotate. I did some drawings of that recently. It looks very cool. But these two stellation diagrams, the dodecahedron one, which is the pentagon face, and the icosahedron, they're not like disconnected. They're not two different separate stellation diagrams. They're interrelated inside the forms. So one of the earliest forms that I discovered, which really kind of set me off in a really new direction, which was the KNEW direction, big time, was the golden hexagon. When I started working with the golden hexagon, which I discovered with the geohedron model that I have a number of videos on, I came out with the golden hexagon. And the golden hexagon, the first form I made was an icosahedron version of it, which is basically like a stellated, truncated version. Well, this form happens to be kind of like the outer hull of the of the echidnahedron. So I tried to place that little pentagon face right on top of that central opening. Well, all those little pentagons are going to match up at the same place. So that was one of the first forms I built. At the time, I had no idea that it was, composed of the echidnahedron or even the nine-pointed star within it. Couldn't tell from the surface. That's why a lot of this is really in the inner structure. So I drew this in a bunch of different ways. The three perspectives. I can't believe I did these drawings just as when I got started, because I didn't understand how the golden circles worked and all the templates that I've shared with you at that point. I recently started to build this model, but haven't completed it because I thought it looked cool just like this. But this is the same form with the pentagon on top and the golden hexagon faces. Each of these lines crisscrossing here are going to be one of those huge nonagons wrapping around. Just haven't got to it. I was using it more as a hat. So that's that section, okay, about it's already found in the dodecahedron. It's found in the Rhombicosidodecahedron. And now this is some of the early forms that I did when I was just kind of experimenting, and it was just showing itself to me, but I didn't even really realize it at the time that it was in it, because I was mostly thinking about surface planes, but I did notice the golden hexagon. But just below that is the nonagon plane. Now this is the compound of two dodecahedron, and the reason I did this was because in square view I saw that, well, you can make two dodecahedron, one going one way and one the other way, and they'll crisscross, and you have two, right? So I just compounded the two together and came up with this. Now, within this, there's the nonagon right inside, and it has a triangle and has a smaller triangle inside. Of course, that small triangle's extending its edges in golden ratio to give you the 9 points around the outside. So that's what's giving you, like, that's the driving force. Like, as we get more into this video, there's kind of two ways to work with this nonagon. You either can do a tree of light around the large triangle, or have the small triangle inside that one extend its edges in golden ratio. Now, when I look at it through that lens, rather than just compounding two dodecahedron, well, then I'm able to look at it as the octahedron, right? The octahedron is the Platonic solid with 8 triangular faces, right? So that octahedron is this central triangle here, right? So we got the central triangle, and if you put all those pieces together, there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Those 8 planes will come together and create an octahedron at the center of this. Meanwhile, all the geometry that's around it, the other 9 points, are gonna, once again, just fall into place, match up, connect, and then you get your compound of two dodecahedra. So you can kind of do this in zone tools. I had a little model somewhere nearby where you can just extend, you could extend it, but you can only make one dodecahedron. You can't do both, and you can't really close it off. So you just have these little points pointing in both directions, in all 4 directions off the octahedra, but you can't really make the finalized form. But with the paper model, I'm able to kind of do the complete structure. Now, once again, you could take a tetrahedron, right? Because inside the star tetrahedron, we call it, the stellation of the octahedron, we have the star tetrahedron. So you take those same tetrahedral pieces, you pop them together, and you also will create the same form by doing the octahedron, because it's containing the star tetrahedron components. So the greater star tetrahedron produces the same thing, and the smaller octahedron produces the one in the middle. Okay, this is just kind of the basics of how that works. Now, there's just a couple images here. I was curious, well, then how many cubes do we have in there? Because we know one dodecahedron has 5. Then what's going to happen if you bring them together? Are they going to mix and match? Are there going to be any shared cubes? There is one shared cube, that's the 9th. And then there's the other 4 that are unique to the one dodecahedron on one side and the other 4 that are unique to the other dodecahedron. Notice there's some non-conventional ways of viewing the cubes here, right? Compared to just looking at it as a hexagon. Well, that's because there's 5 of those cubes in there, and they all, they take on this rectangular appearance. So you just have to study the dodecahedron in this view to see where those edges are. But these are the cube edges that will all crisscross to make the stars on the dodecahedron faces. We can also, look at it as 18 tetrahedra. So that was a kind of fun one just to do. It's essentially the same cubes, but I enjoyed, just drawing in all the other star tetrahedra because I thought it looked beautiful just doing it that way. And, so there's your 9 in one form. That's pretty awesome. 18 tetrahedra in there. Okay, so as you may have seen in a previous video, if you haven't, I would suggest checking out this video called The New Golden Merkaba. It's just maybe 2 videos back. This really kind of, started to crystallize or get the ball rolling because I've been doing a lot of videos indirectly on the Tree of Light and the Nonagon and how it's working. But this is one of the ones where I was starting to be, it really was the start of an expansion of like a 2 or 3 week or maybe 4 week expansion into where we're headed in this. But what I did was instead of having the central this be the octahedron, I said let's do that with the tetrahedron, right? So we've now taking the whole tetrahedron face and placing that in the middle, and now we're going to extend that out into the golden proportion tree of light around it, and we'll fuse that back together. And this one made the new golden Merkaba, which then there's something that is still very cubic around these, and I want to turn it back into icosahedral symmetry because it has, it seems like that's the next level, is to go through that transition and then go into icosahedral symmetry and see what it looks like that. And this made what I found out to be was called the truncated dodecahedron, I believe. Quasi-truncated dodecahedron, something like that. But I didn't know it at the time. I'm just kind of following out, intuition in the new style. And this was a great drawing to do. It's like the ultimate expression, in my opinion, of the golden seed of life. If you haven't seen my videos, basically what the golden seed of life is the seed of life with golden ratio circles. And for this one, I had to have 1, 2, 3, 4 levels of golden ratio circles. And, what I did here was just say, well, let's just do all the connecting lines between to make all the hexagons, and bam, there's all the points to make the perfect decagons that you need at all these tilted angles, the golden rectangles and the golden hexagons as well. Pretty cool form. We're going to come back to this one in a future video because I'm actually going to take this, return it to square view, rotate it on itself to do a compound of 2 of these, and then evolve it into the next icosahedral version. So there's kind of a builder's workshop that I kind of go through with these forms that I'll be talking about in subsequent videos. We're kind of going to do the basics at this point here. Now, this is from last year, probably about a little over a year ago, when I first took my plunge into saying, what's going to happen when we go past a single dodecahedron and turn that dodecahedron into its next level form, which is going to be a compounded version, because I started with the compound of 2, and that took me to more of a kind of octahedral type of version of that, right? Because it's like an octahedron almost, with little points where the stellation, where the cube underneath would be poking through. And I have other videos where I talk about that one, and I have a video on this one too. But when I take 6 of them, and meanwhile, some will only do this with 5, but the 6th dodecahedron is key in the process. It's kind of like the one that the other 5 orient around, and we'll talk more about that when we get to the icosahedra. Well, this came up with the form that I discovered then. I actually recently just built it by hand and just to study more in detail to really take a look at those cross sections of the planes, because when I first glance at this, I don't know where the tree of light in this is at all. I wasn't calling it the tree of light back then, and I was, vaguely familiar with the Nonagon and Coxeter star, and mostly looking at it as an icosahedron stellation. But there are a few tiers of the tree of light within here. I'm just going to focus on these black lines, the three of them, and then connect the dots from the top over to here through the pentagon down to the bottom, root 2, root 2, 1, root 2, root 2, 1, root 2, root 2. There's one of the nonagons below the surface once again. The reason why I have this hexagon, and I forget the proportions of this one, but the reason I have this one is because it's an important one that you're going to see later on, is in the video, is part of the stellation, the larger stellation or expansion, the tree of light expansion diagram that we're going to take a look at a little bit later in this presentation. But this is a really cool form, the way it comes together. I think I'll call it the star dodecahedron because it's got these awesome long elongated stars. But these star arms here, they make these perfect squares. So it does have 30 perfect squares all the way around it. And it's hard to actually say what is the internal structure of these after a while. I mean, I could count up to maybe 30 dodecahedron in there. It could be a compound of 6, because you can also do that out of that compounded dodecahedron, which had, 9 cubes in it. So it might have nine cubes in it. I mean, not 30 dodecahedron. It might have 30 cubes in it. It's really tough for me to figure out those numbers, but this is the overall shell of the form. And there's other ways to create this. As of this morning, I realized that we're going to get to this form. I know we haven't gotten to it yet, but this is an important one, the cube octahedron, which is a rotation of 5 of them. So it's an icosahedral version of the cube octahedron that I'll talk about in the next few slides. But that form has triangular faces, and I'm showing you one of the cube octas in here. That is how it's connecting to the underlying vertices of creation of this form, which there are 5. So this is when you might want to just pause and just see where the dots are connecting. But that form is inside this, right? Because it's a cube octahedron. So if we truncated this outer form, we would come down to this cube octahedron shape. But there's this little triangle, the black triangle, and I know I switched my colors. Here it is in red. And this is square view, so I'm actually in 2 different views. But this triangle, and there's the red triangle, they're the same, the black and the red one. Now, if you just extend that triangle, now this is off of the cube octahedron, which is probably a new form to you, unless you saw my video on it a while ago, that it will, if you extend that top triangle into the tree of light, that is going to create that golden the tree of light around it, right? So it's going to create all the vertices necessary to create the compound of the 6 dodecahedra. And that's the blue form here and the black cube octahedron underneath. So even at this kind of next level of forms, right, we're dealing with 2 evolved forms, the truncated Platonic solid, the cube octahedron, and the dodecahedron, which is the number of cubes in there, and the 6 dodeca, let's just call it. If we still do the tree of light on this kind of evolved form, we still get a result of the relationship of the next higher structure form here, which is this cube octahedron, which was just really awesome to me that it continues to work at higher and higher levels. There's probably not any triangular face that you can't do this to and won't come up with some sort of really interesting result of form that is in a lawful type of structure. It's not, I'm just making stuff up. This is following a process that has a relationship to the golden ratio that is inherent in extending those edges. And there's a perfect circle that fits around this form. And that's giving you the 3, 6, 9, giving you the triangle, the central triangle, and the 6 points around it that are those golden proportion extensions that is just a really fun nonagon to do building with of the different structures and these more evolved forms. The equilibrator, as I call this one, because I felt it had something to do with the Earth grid. Here is the Becker-Hagen's Earth grid that's on, you can get for the Google Earth, and you can overlay that and check out some of the grid lines. And I saw that golden hexagon, which is black here, there's an underlying structure once again underneath that top triangle, which actually is what's making all the points of the form, is this golden hexagon underneath, which is going through the pentagon, not just on the surface pentagon, right, the outer edges, it's the star. And you follow that around. Well, that's the same one. There's the floating triangle. And notice that triangle will fit right into those yellow golden lines right there. And the Icosahedron below it is also part of the grid structure. So this is how the cube octahedron isn't just a single form of one, it's this 5 in this case. And in my future videos, I'm going to show you the next level of this one, but for now, we're going to work with this one. And so there it is, the equilibrator and the golden hexagon below. This is one of my favorite drawings that I did with this one maybe over a year ago, around that time when I decided to rotate it to Pentagon view. And it has, it's just, I'm showing you like in a wireframe structure here where you can kind of look and see the front and back of the form. And this just has amazing, beautiful symmetry with the golden ratio circle pattern that was used to derive it below, outlined in a perfect decagon with the 5-pointed stars circling the outside. Just a beautiful form, right? Pretty cool to think that that's part of the Earth grid structure, right? With these channels that go through the middle of it like so. Very, very cool. Okay, so as you see, I'm working with the Platonic solids here and their truncated versions. So we've done the cube and the cube octahedron. Now we're going to go over to the Icosahedra compound. And so this is one of the first, after I did the dodecahedron, I said, let's see what happens with the Icosahedron. Doing it with 6 was really important because what I'm doing is the first initial setup, and maybe the next slide, first initial setup goes through this process, right? It goes through a compound of 2 to make it into an octahedron. This is really easy to do in square view. It's easy to draw on the golden circles. It turns it into a hexagon face. And then that creates the initial one that you then rotate that all the way around, and that produces the compound of 6 icosahedron as well. Okay, they're doing this truncated version of an octahedron, let's call it, but really inside it is the two icosahedron, 2 of the 20-sided Platonic solids. All right, but this is the first way I did it because I didn't realize that truncated octahedron version, it comes up to be the same thing in the end, which is this form here. And there are 6 icosahedra in this, let's just say easily. Remember, if I do it with the doubled version, I don't know, there might be 12. It's hard to get a hold on the numbers because there's so many different ways to grow this form. So it is really like a unique form that has inner forms that create the vertices in a variety of different ways. But when I first looked at this form, I was like, I'm not sure. I mean, it's got these flat rectangular faces, which happen to be golden rectangles. But I didn't really understand what I was looking at. I just like, okay, just, got little points out here. I could see the icosahedron in there. I could see how the other points made these little triangles. But I didn't notice every single thing, once again, was made up out of the tree of light. So here's one tree of light that's going to give you the top vertices. So here we go. 1, square root of 2, square root of 2, 1, square root of 2, square root of 2, 1, square root of 2, square root of 2. Now, as that goes around, it's giving you the base of a triangle, and it's going to give you the pinnacle of that pentagon, and then we're going to go down here, base of the triangle. Now it's going to do that all the way around. So every single one, and here's another one we could look at here, right? So that's going to be base of a triangle and the tip of the pentagon. So this whole thing is just basically enwrapped in the tree of light, which is so cool that it's just, on the surface, it just looks, it's more than polygons, I guess is what I'm trying to say, right? There's layers beneath the surface that are creating the structure of the form that are not just polygon faces. And if we just look at the faces for what they are, we just say, oh, it's got a lot of irregular stuff going on here. It's got, okay, golden rectangles. I don't know, what's the proportions of these isosceles triangles here? Oh, okay, at least we got an equilateral triangle. But if you look below the surface, this is highly ordered, highly organized structure, all built over that nonagon. And if you can envision in your mind that these are actually circles, they're like discs because there's circles that go around each of these. So it's like 20 circles, intercircling one another as we go around. So here's the version I showed a little bit before, because as I said, there's so many ways to do this. I'll show you a few after this, but this is with the truncated version of the octahedron. I did the same thing, thinking I may come up with something different, but I didn't. This is the same form underneath with the nonagon, as well as the equilateral triangles and the golden rectangles that gave me the same vertices in the end. Now, you might have to study this because this drawing right here is drawn as like a cubic version of it, right? Like as if it were in a cube. And this golden hexagon, you can't plop down right in the middle. It's tilted, so you have to, because it's going into icosahedral symmetry here, so it's going to reorient that triangle. So see if you can pick up one of the golden hexagons, and you could start at one of these center points, or one of the squares, for instance. Here's a kind of blue square, and there's the square of that one going over the golden hexagon, going down, going over, going back up. There's one of the golden hexagons. So that's what's going on around the whole form. There's another way to do this that I was thrilled about, that I was able to construct with zone tools. And I actually didn't know, I was like, now that I know how to build this nonagon, I was like, okay, let's see what happens if I do it around an icosahedron. What am I going to come up with, right? Well, this blue lines in here are an icosahedron in hexagon view once again. And as I did the nonagons off of those triangles, so the nonagon here is the big equilateral triangle. I'm not doing the phi extension. So I did it all the way around, and then I came up, I was like, oh, I got these little triangles. Huh, that's interesting. I didn't connect the golden rectangles because, it didn't do that. I'd have to add those in after, but I just followed it out and did it. And then I was like, wait a second, this is that small little triangle form that I did maybe like a year ago and haven't really looked at much since. I haven't even built it yet, honestly. But I just built it out of zone tools, and I didn't even know it was possible. And there it is, right here inside the core of the form. So that was pretty surprising to me, because then I knew I was really onto something unique and special about working with this nonagon, because it came about as a surprise, and all I had to do was just extend the equilateral triangle, make the nonagon around it, and bam, there's the form. Now remember, that's not one icosahedron, that's 6 of them. And I think I missed a little note on one of my slides back here. Maybe it's coming up. Yes, this one right here. See, this, when I first came across this form, I took off the 6th icosahedron. I made it back to 5, right? So I chopped off the most important part are the tips of these pentagons. And I went on to, Wikipedia, and I saw that, Kepler and, the modern day geometers after him, they would have just called this the rectification of the Icosahedron, because they don't put in that 6th icosahedron. They don't even probably look at it as an icosahedron. They look at it as an Icosahedrodecahedron, right? Which is a different Archimedean solid. And they've just removed this point, and we just focus on the golden rectangles and the 2 equilateral triangles, and it's just a variation of the Rhombicosidodecahedron, which is the first form I showed you. It's just a variation of that. Yeah, that's all it is. It's just this, but with golden rectangles instead, it's an icosahedron. But if you leave out the sixth icosahedron, then you miss the whole thing. You miss like the whole tree of light expansion. You miss everything that's going on with all the underlying geometry of how that mathematical wonder of the tree of light is driving everything underneath it to produce these incredibly beautiful forms, interconnected forms. So that's why it's more than just some truncated icosahedron. Okay, so anyway, we could grow this, so we did it there in Zoom Tools, which was awesome. And there is really another way to create the compound of the six icosahedra. And this one I discovered recently too, was if you take your icosahedron, now this is the one they said it's just a truncated version of, right, into a golden rectangles. If you take that, two different views again, remember this is a hexagon view and this is the square view. So this red triangle is the same as this red triangle. And if I take that icosahedron, which is down in here, now this red base right here is the same as that red base. It's actually below these dark blue lines here, so you don't really see it. But this gold line extends here, extends over here, gold line there. So if you flip it up, basically what I'm saying is that this red pentagon is the red pentagon of the icosahedron. So if you extend the lines of the icosahedron, then you will produce this compound of six icosahedra by just extending the inner structure rather than the icosahedron. Now, that all makes sense when you understand the stellation diagrams, because inside, remember that the midpoints of an icosahedron, if this is an icosahedron, the midpoints are the icosahedron triangle in the middle, like that. So that's just the way it goes. So we have always both together, but we extend one in golden proportion or the outer triangle. It doesn't really matter which way you do it. The ultimate thing I'm saying is it produces the same thing in the end. Now I'm showing a different form here that we haven't gotten to yet, but I believe that's up next. So this is not, the light blue one here is not the same as the dark blue one. This is the ultimate expression of the icosahedron, which is up next. Or not the ultimate, there might be one more or many more past this, but this is the one that's been sticking around for a while. It's actually the first one that showed me that this Nonagon surface that's been below the surface of all these forms I've been building creatively over here for a little while. This is the first one that rose it up to the surface that I was like, holy smokes, wait a second. It took me like 2 weeks to actually discover that the Nonagon face was the stellation diagram. Like, you know, Coxeter or Bruckner stellation diagram. I didn't realize it off the bat. I was just like, oh, this is awesome. I got a Nonagon face, but it's irregular, so I don't think it's going to be that useful. But it turns out to be one of the most useful planes that I'm working with at this moment. But I'd say it's going to be one that sticks around, and it's relatively easy to incorporate into your drawings. And remember, you get it by extending in the basic seed of life, extending those edges all the way out to the outer circle. So it brings in the outer circle that contains the seed of life, and that's an important critical junction between line and outer circle. Okay, so onto the compound of the six icosahedron. So after I did those other two, the dodecahedron and the icosahedron, I said, all right, let's get down to the icosahedron, because there must be something going on. Now remember, the icosahedron is like a cube octahedron in that it's meeting at the midpoints. These vertices are meeting at the midpoints at the center of the edge of the dodecahedron. So it's meeting right there, right, at the center of each of the dodecahedron edges and the icosahedron edges. So it's like the joining point of all of them. If you have the rhombic tricontahedron. Yeah, if you got this one, if you got the rhombic tricontahedron, that center point on each one of these diamond faces is where the icosahedron meets. So you'll get triangles, 20 of them, and the 12 pentagon faces for the 32 faces overall. And we're going to take all of those together because I figured if I'm doing these compounds of 6 of the other form, well, there must be something going on internally that's going to produce something that is the one that's unifying form between those higher level compounds of the dodecahedron and icosahedron. And this is what came up. The nonagon became straightforward the prominent feature with 20 of those faces. We will return to look at that one more, but I wanted to show you just some other nonagon face experiments. I started to do tetrahedron, octahedron. I took 2 of these tetrahedra that were truncated into this nonagon face form. It actually turned out to be an octahedron at the core of them. I put 2 of them together. It fit perfectly in a sphere. I started working with it more, and then I basically discovered, oh, wait a second, it's inside the Icosahedrodecahedron compound of 6 that I did. Okay, so it already was it. This kind of star tetrahedron-y thing that's truncated with golden hexagon faces with nonagon faces on the inside basically ended up with where I started. All right, well, let's try this one, right? I'll do 2 Icosahedra, right? And this one is created with the cube octahedron. Now, this is a really cool link. I wish I had a better drawing than just putting the zone model in. This is a square view. There's a cube octahedron in the middle. There's another larger one. And when you get to the triangle face of the larger cube octahedron and you extend those in golden ratio proportion, just like I've done in all the others, you'll create 2 Icosahedrodecahedron in a compound from the cube octahedron. One single cube octahedron, extend those edges in the golden proportion, tree of light, boom, 2 Icosahedrodecahedron compounded together. Really awesome that happened. So I was like, ooh, this is something new. What's this going to do, right? Well, then I realized that this was actually going to do the same thing. It rotated this around with all these drawings. I'm doing all this hand drawn on the iPad. Rotate it around. Well, there's the golden hexagon inside the nonagon. And if I put another, because this is only one of them, so I've got essentially 6 of these rotating around, giving me the cross lines and all the decagons and all the faces to give me all the vertices. It's the compound of the 2 Icosahedrodeca. And I found out that this form with those golden hexagon faces and that little point actually turned out to be this, right? I just closed off these edges and made it a full flesh form. So this form is actually 2 Icosahedrodecahedron. And if you study it closely, you'll be able to see where the pentagons are. But it's better if you have that in hand. But on this one, you can see the pentagon faces. Let's see, I don't think I'm holding it in the right orientation for you. Yeah, I think I got to rotate it a little bit so we can pick up where those are. But I'm going to keep rolling with it because I think I go out and around like this and they're meeting up on the backside there. Okay, so anyway, but you get the point. We ended up creating a compound of 6 Icosahedrodecahedron again. So there's a little bit of a process that I described earlier. It's like you take 2 of those forms, you compound them together, 2 dodeca, rotate that to icosahedral symmetry, you come up with that star dodecahedron. You take 2 Icosahedrodecahedron, compound them together, rotate them around, you get the next level up. And we can continue to do that if we choose to. But some of the geometry asks for that and calls for it in the diagram, so I've gone a little bit further than what I'm showing you. And the tree of light continues to grow, and next time we'll talk about what happens to the polygon faces as we go more and more into that evolution of the higher order forms. Now remember, they're all starting with the basic roots of the Platonic solids. They're just a little bit more, more unified through this tree of light, and they're given a way to grow and interconnect with one another in ways that I haven't quite seen before. And the relationship between the golden ratio forms and the non-golden ratio forms, meaning the cube and octahedron and cube octahedron, tetrahedron, it's really about the triangle now, right? And this triangle is the driving force of golden ratio proportion that's extending and continuing to match up. So the dance between non-golden and golden forms is really awesome. Okay, so 2 more ways to create the compound of 6 Icosahedrodecahedron. Well, similarly to before, well, if we take the Icosahedra by itself, right? Remember, we've got 20 pentagon, 20 equilateral triangles. Well, let's just go ahead and put trees of light around them, right? Boom, tree of light, tree of light, tree of light, all the way around. What do you know? That gives me decagons. It gives me these isosceles triangles, and I have now produced the compound of 6, just like that, by just putting tree of light around this one. Well, that was easy. I didn't have to do all that compounding stuff that I did before. I could have just done the tree of light. Another way to do it, of course, is, well, this is going to be a unique one because now we have something new to the core of our stellation diagram, which I'm about to show you. We have a new triangle. And that triangle isn't the regular triangle of the icosahedron stellation diagram, which is an icosahedron itself, the triangular face. This is the compound of 6 icosahedron, right? So this is the small little triangle that's at the top of that form I showed you before, remember, with all made out of trees of light. Now, that one, when we extend that into golden ratio proportion all the way around, that's going to match up, and that will give us the compound of 6 icosahedrodecahedron, right? So we're operating with the tree of light now at the next level, and it's the new forms that are being developed, like I showed you with the compound of 5 cube octahedra, creating the dodecahedra. What a cool link that is, right? And now we've got this new icosahedron extended out. Now we got the compound of the 6 icosahedrodeca. So I'm starting to think that these forms are just more or less unique in themselves. Doing the inner structure of the, knowing that the inner vertices were related to those underlying structure of the compound of 6 forms, right, was a start. And now they're just kind of off and running and just doing their own thing by themselves and operating with the tree of light to recreate and reconnect with one another in awesome ways. So here's the compound of 6. This is one of my favorite forms because it was the first one that I said the Nonagon face had come to the surface for me. I built it. It's the biggest structure, and I have other models that are all matching this scale. It's a big one. And I also love that I drew it first in the hexagon perspective, which was a very tough drawing to figure out at the time. It's still pretty tricky. But then months and months later, I just happened to came back around by surprise, basically, and was able to draw it in pentagon view. And then a day or two later, I did it in square view. You'll see this pop up periodically in older videos throughout the year, the previous year, because it was, part of my growth as a geometer was to get to know this form and understand the techniques of how the golden ratio works and how this nonagon works through learning to draw these 3 forms from those 3 main perspectives: 60 isosceles triangles, 20 nonagons, and 12 decagons. So I'm getting close to the end of the presentation of just part 1 because I have a lot more that I thought I'd get to, but I believe this is going to be a couple parts, like I said. These 4 forms all to go together in a few ways, and I'm going to call them the core 4 here because they, as I built out the stellation diagram, I saw that they were going to continue to repeat in a number of ways, which I'll get to, and they're going to be the growth for the next level that's beyond this. Okay, now that's going to be in future videos, but we have the 6 icosahedrodeca, 6 icosahedra, 6 dodecahedra, and 5 cube octahedra. Well, why not 6? Well, that's because I'm still showing you kind of one level back for this one, because this one just basically caught up to a 5-fold symmetry, right? These all were 5-fold already, right? The Icosahedrodeca already started as a icosahedral symmetry version. Icosahedron, yes, already icosahedral. Dodecahedra, already. This one has to go through its next transformation, which I've done, but I kept it at this because it functions the same within the forms at a base level until we get into the surface, into the interior planes of what's going to happen to this when we do transform it. But stay tuned to future videos to check out what happens with the compound of 5 cube octahedra when it takes its jump to 6. I know this looks like a tangled mess over here in the middle, and it is more so that because I didn't draw it together, I just kind of tried to layer these forms on top of one another in scale. But the relationships of how they interrelate are actually going to be more revealed in the stellation, or I call it the nested expansion diagram, because I don't look at it as much as a stellation diagram, because it's not just about stellating one form. It's really about the expansion of the forms as we continue out on two planes. This is an important part, is there are two planes showing up here that I'm outlining here for you. One is going to be the face plane. So this is where the face is above the central plane of the central axis plane of the form. Above it, what's going on up there? Well, this is how the faces will go. And then below that is that core plane. And these are two right now scaled the same. So if your face of the blue, or let's do the black, that's the golden hexagon that is of that cube octahedron. Now remember, it's below the surface of the triangle because I already have stuff going on above this, right? Because I'm starting this stellation, or the expansion diagram, on one of the triangles of the small icosahedron compound of 6, the small little triangle of that guy. That's the one in the middle. Then we have the icosahedrodecahedron around that. Then the red one, well, that is a layer that is inside the dodeca 6 compound. Now, remember I said earlier, I'm going to come back to that irregular shaped, odd-looking hexagon that doesn't look at first glance like it has golden proportions. But just revisit that real quick, because this is how a big part of this is realizing we're working below the surface here. That's the same as these lines right here. So we have a vertex above this, but this is the first point of contact where we have a plane that shows up. Then we have another plane below that. So you could build this expansion diagram off of any of these planes, but this is the first one that I can do with this dodecahedron, and I've already got stuff going on inside here. So within that plane, where are we here? Within that plane, I've already got inside, nested within there, is the Icosahedrodecahedron of 6, right? Remember, that's that Nonagon, which is this Nonagon right here, the blue one. That's already in there. I have one triangle represented. There are actually two other triangles in there. Those are rotated triangles of the other Icosahedrodecas that are in there. And I've also put a Nonagon around the blue one here, which is the small octahedron, a small icosahedron, because that's got another level higher order form, because that's going to rotate around and give you the next expansion of that form. But so I think that's going to be the limit that I take it, because we're hitting the 9 point. You keep going, you get 12 and 15 and things like that. And some of those will show up on their own. But this is the next limit that I go to. I'll show you one slide at the end that shows you kind of a little bit of a build out. So then we have that hexagon, which is the big one, which is of the cube octahedron. Let's just go over to this one here. That's that big golden hexagon right underneath there, right? So that one is the black one here. Wish it was same colored, sorry. And then we got the blue one. And there's your icosahedron. That's the compound 6 icosahedron. Of course, that is this big one right here. So all that's going on the surface in here. Okay, so that's one plane right through, all based on the plane that goes through there. So this little triangle is not the one that you're seeing. There's one already embedded in the overall context, not too far below. And that's going to get into how this grows, which I'll get to at the end of this video. There's a few ways that it can grow. This is zone toolable, and I built out quite a little large model to at least build it to here. Doesn't make sense holding it up. You could see it right there. I didn't get the last Nonagon around the central triangle, but once again, this corresponds, in fact, pretty much 1 for 1 right over top of my drawing. So another way to work with our sacred geometry drawings is to work with them in the expansion model. I'm going to have an awesome course coming up on really working with the this kind of new geometry synthesis and system of drawing all these new forms and working with these stellation diagrams to kind of show what's going on with them in a coarse format that breaks it all down. And as I'm saying, you are here, right? Well, what does that mean? Well, this is in my process when I started with that face plane, which is way, way, way down in there. You'd have to zoom way into this diagram, which I can in the iPad, zoom way in there. And basically I followed that plane way out. I mean, all the way out to here from this little face plane. And I'm picking up other forms that I'm not mentioning and the repeating of these forms as we go throughout there, but at different levels of those planes as we go further and further out. So part of that course is going to go through that expansion at little bite-sized chunks. There's about 9 key levels or so that you go through, and you see every single interrelated intersection going on. And these lines that are way, way in here, if you start extending these edges out, you'll realize they go all the way out to the distal end of this, and there's really no disconnection from the core to the end. And really the beginning form is the end form, right? It's all that linked. Like the big icosahedron is your basic flat hexagonal plane. The only thing I didn't talk about here, and I know I'm spending a lot of time on this slide, is these outer rings, right? Well, when we do get to the core plane, which I have to explain in a lot more of another video, is we do hit the hexagon plane and the 9, right? We're dealing with 9 nonagon. Those two compress and you get the 18 points compressed together, and the 2 trees of light come together, the top and bottom, to the central plane, intermixing with the hexagon plane, which turns out to be at least 6 hexagons, as you can see here. And this will come when we get to the cube octahedron next level, beyond the one I just showed you today. The compound is 6 cube octahedron. We'll give you 24 vertices around the outside. Now, the core 4, once I laid this out and I was like, let's put some circles around it, let's see how it goes. Well, I'm able to build them out and the circles match up all the way out to here. And this extended circle is beyond the outer edge a little bit. But so far, all these circles nest up all the way out to the flower of life. So we've got our 19 circles of the flower of life right through this core. Now, here's a little shout out to Gianvallo Melchizedek, because late last night, I was like, I got 24 spokes here, right, that are going off there. And I know in his book, when I read it years ago, he went off about these 24 spokes, these 8 diagrams on the wall in Egypt, the huge secret or something about them, not even a secret. He didn't really understand what they were. In his book, he was really trying to discover what these were. And at first, he thought they were 24 equal lines, right? So this would be 75 degrees. This would be 105 even, right? And then we'd have, 60, 30, 90 progression all the way around. But luckily, he caught it in his book right before it was about to go to print, maybe a few days before. He discovered that these lines, the golden lines that I have in here, he said were off by less than a half a degree. He doesn't say, unfortunately, which direction that half degree is. But last night when I started measuring the angles of this, I said, oh my gosh, I better go check out and see what was he talking about there. Well, he said it was off by half a degree. Well, these are off by half a degree. Could this be related to that diagram? Could this be some sort of inner geometric structure? Because in his book, he mentions, well, if they knew something, the ancient Egyptians, these Egyptian spoke wheels that he felt was like the key to unlocking where they went and the stars and, like how we discover more about ourselves through this whole process, things like that. He basically said that they were pretty big, but he only touches on them in a few places in the book. But he thought they were equal, 24 equal spokes when he did it. But that would be easy to draw, 24 equal spokes. We don't need to even do the flower of life to do that. I can do it out of an octagon. So anyway, this is a bit of a a bit of a mystery, but it's even easier than everything I just showed you. And if this were the case, and this is a shout out, anybody who knows them, I'm going to really try and get in touch with them about this. Because if they are off by this degree, that means that the ancient Egyptians who carved these into these walls, they must have known this diagram, because you don't need all the Nonagon, stellation, you don't need all the forms and structure. Maybe they knew all that stuff too. But all you need to do is just do the central triangle. Very first thing I showed you, out to the outer circle. And automatically you're going to get those proportions. Instead of just having 18 points, well, just extend the 30 and 60 lines all the way out, and then you'll have your 24 points, and there won't be 24 equal points. They'll be off the gold lines, like I said here, which are the blue lines in this diagram. They'll be off by that less than 1 degree, less than 1/2 of a degree. So anyway, just a little bit to explore there. I'm curious about that. I'll let you know if I find anything out, but I'm definitely trying to get a hold of him on this one, because he sounded like he was quite intrigued and quite interested in at the time, and maybe it's still an unsolved riddle for him. Maybe this did it. Okay, last thing that I want to get into here, which is what's going on with the expansion of the forms that are going on the base interior level, right? So if we do like the full-on star going on in the middle, right? So we got the flower of life, or the seed of life, laid out in here. And then we've got our inner radiating star that has an awesome loop right in the middle, where they meet those same 24 points in the middle that I just described. So you got those 24 points, which repeat themselves out here. And then we could have another 24 if I extended those lines at the outside. And that's the way this diagram should be. When I do the next power of the next 5 cube, the next 6 cube octahedra, the next model above, that will give us the 24 points. But this is what I want to illustrate. From the central circle, you might see there's a lot of little dots going on here. I've zoomed into it right here. So this is the same thing. At that point in the diagram, this little section, let's call it from 0 to 1 right there. As we work our way out in golden proportion from that radius of that first circle, which I'm going to do here, 1, we got 5 squared, 5 to the 3rd, 5 to the 4th. This model will reproduce itself at 5 to the 4th power, right? May the 4th be with you. To the 5 to the 4th power, every single time as we extend beyond this model to the next one, we will hit 5 to the 4th again. And beyond that, 5 to the 8th. So we're going to continue to increase at that 5 to the 4th level. And this little diagram, which I'll show you in a future one, I'll blow it up a little bit bigger. I'll probably redo it a little bit. But these are where all the planes of those different faces are meeting here. Here's a little icosahedral cap sticking off to the side. There's a little tiny dot in the middle. That's one of these larger truncated icosahedron, another truncated icosahedron. Well, from the little one to here, that's jumping 5 to the 4th and another 5 to the 4th above that. So that's one expansion of the 5 to the 4th power, one way that it grows, which is really unique, because the regular, and this is on the base horizontal plane through the core of the form. A lot of the way the other models of just the kind of standard dodecastellation kind of way of moving about usually moves by 5 to the 3rd, right? And that was a lot of the work on the Russian pyramid was also 5 to the 3rd. So I thought that that might follow suit here, but for whatever reason, in working with this, we have more of a doubling thing going on in this pattern than I've ever seen before with how the golden ratio is expanding. For instance, with this model that I did, which is this big one that I'll hold up once again, which would just look like about a lot of white dots, but I can zoom in on those triangles. It's the same as there, right? Well, basically what I did here was I took the cross, I built the next level above it, right? So here's the next icosahedron of 6 above. There's the littler one below, right? And that's what you're looking at in this diagram right here. And the way this extends is you can do this forever too. It's all the edges of the whole form. Any edge you take will basically take the lower edge extend it by the golden proportion, right? And then double that extension, and that's your next edge length up here. Now, if I did that, I take these two struts, I extend that by the two smaller little ones, so extend by golden proportion, double that, and then I'll get my next one. So this is extending by phi in a doubling sequence into the golden ratio sequence that I'd never really seen before, but I just really love that extend by phi and double the extension. Now, I'm just showing you the central triangle, but I can assess the whole form. Every single piece of it can grow like that. And it's not just the icosahedron. All those core four forms and the other ones associated with it are all doing that incremental jump of extend by phi and double, extend by phi and double, as they kind of progress that way. And then the phi to the fourth power is another sequence going on inside that is really jumping very fast and big jumps, right? But then through there, we have a lot. You may ask, do they meet up? Very close point at about 46 point whatever in the sequence, the number 46. Now, they meet just about, just a little off, but then they continue to kind of go their separate ways. So I'd have to follow that out a little bit more. It's certainly a keen area of interest and research. This is just presenting the numbers, but these are the two ways that the forms grow rather than just being isolated stagnant forms. The core four are here to grow with the tree of light, right? And the tree of light's going through that because all these tree of light edges are extending by phi and then doubling. So that's the growth process of the tree of light, kind of on a material level, let's say. And then you've got this amazing quantum leap happening at the phi to the fourth power, which is also a kind of feels a feel of a doubling sequence to it in there too. Okay, so anyway, there's a lot more to explore. I'm just getting started with this. I got a gazillion drawings, and this is really just a recap of where new geometry has been. And I'm starting to synthesize and crystallize many of the trails and routes that I've been following. And, you could tell most of the white forms that I've done, that was my early stages. And now I've gotten a lot more colorful in my creativity. Basically because I had to stop building with panels because the forms got larger and larger as I went, rather than the basic core Platonic solids that you see here. And as we go out, we have a lot of forms in the middle, which represent kind of that doubling sequence, or, taking a core form and then kind of doing a square view version of it, and then moving into icosahedral symmetry until we get out to the kind of ultimate expressions of the forms on the back edge over here. And we're going to get to those future videos and the other hidden depths that are emerging in this process, flesh out a little bit more in terms of, the expansion rate and things like that as I look into those mysteries a bit more. All right, well, that's quite an overview of the whole video. Hopefully that was full of jam-packed with lots of good visuals for you, pictures of the forms. Hopefully it was an easy synthesis to kind of follow the progression. Basically what I wanted to try and review in this was basically how the tree of light extends from the Platonic solids based on those triangular faces being key. But it's growing the dodecahedron. The upper level forms are growing as well. So each of the Platonic solids can either, the triangular faced ones, they either put a tree of light around them or extend the edges of the tree of light. They grow into other forms. I hope that's documented well in the video. There's so much more to this expansion diagram that I'm showing you here. And this is what I meant by the upper plane. So that is the doubling, extend by phi double sequence. And then, of course, this is the tree of light. This is where it started, right? Or not for me, but took me a while to recognize. But this is probably the most ancient example that we have. I made out of Zoom tools. Most ancient example of an Archimedean solid, which was probably constructed at the time, of course, with just seeing what we can do with triangles, squares, and pentagons, how we can put something together, right, that would produce a shell that would kind of wrap around and keep its proportion all the way around with regular edge lengths, right, all the same edge lengths. Little did we know, or maybe we did, I'm not sure, but the Nonagon starts to show up with inside that form. So it's definitely a lot older than stated, or than I realized since the 1900s. But the work with the stellation diagram was unique then. I don't believe anybody's done that then. This is going to be an expansion model of the Nonagon, so stay tuned. A few other things. I got a drawing class coming up this Saturday, which is going to be the 1st of July. So that's going to go over this and also my previous video that worked with Robert Edward Grant's solution to the problem of Metatron's cube, which I did a video on and addressed some of the issues that he brought up there. I'm going to do both in one, whatever we want to emphasize more. There's not really a lot of drawings to do there, so we'll probably do something related to the material that I just sent. That's going to be 1 p.m. Eastern time, Eastern Daylight Time, and I hope to see you there. If you're interested in joining me for an apprenticeship, I have one coming up at the end of July on the 31st. Now that's 8 weeks. That's a real deep dive into this material, and it will have parts of this tree of light component. But the real class of this tree of light, which is going to be all about that and how to do these new forms, that's all going to be very cohesively done coming up in the fall. Please subscribe to my Facebook group, New Geometers. That's a fantastic group with some of my apprentices on there and other great, passionate, interested geometers sharing all their work, good conversations, and amazing drawings there. New Geometers Facebook group. And please subscribe to the channel, and I'll see you next time. Check out New Geometry courses for all the other programs that I've got there. All right, now I'll see you next time. All right, much love and appreciation. Till next time, keep that tree of light growing. I'll see you.